Hello, and welcome to SciShow Talk Show, that day where we talk to interesting people about interesting stuff. Today we've got YouTube maker of MinutePhysics and also sometimes physicist, Henry Reich. And I see that you have brought today a bunch of decks of cards, which I take as that you're going to demonstrate something to me, and I may be made uncomfortable by it.
The goal here is not to make you uncomfortable, unless it is by what I'm demonstrating with the cards, not by your abilities to do things with the cards.
So like the last time you were on when you made me feel like an idiot, which is fine.
That was not my intention.
I know it wasn't.
So I want to talk about some weird features of statistics.
Okay.
And eventually might get into how they actually apply to physics itself, but they're general, it's a paradox in statistics that is very important to know about that most people probably don't. Okay. There are lots of paradoxes in statistics that people don't know about that are important to know about. This is one. So I'm going to demonstrate it with cards. We've got two decks of cards here. One deck has birds on it, like the golden eagle.
Good birds. I like these birds.
And the other one is the VidCon deck of cards.
VidCon deck of cards.
So what I'm going to do, these are just the big rest of the cards. We don't need those. Is I'm going to put out some piles for you, Hank, of cards. And this first demonstration is basically I'm going to make a pile, two piles of cards. And you're going to tell me if you had to choose a card randomly from each of the piles, which pile would you choose them from? So here we have, and the goal is to get a red card. So here we have a single black card, and we have one red card and three blacks. Which pile would you choose from to get the greatest chance of getting a red card?
I mean, I think I would go for the one that had a red card in it, Henry.
That's very good, and that is very correct. So now we're going to put those aside here for a second. So basically, you said the bottom pile, the VidCon cards, are the ones you'd pick. And here, again, are another set of piles. Here's one that has one red card, and here's one that has three red cards and a black card. Again, your goal is to have the greatest chance of getting a red card. Which one do you pick?
I'll pick the bottom one.
Right, the bottom one, the VidCon one, because it's a 100% chance of getting a red card. So in both cases, you had a better chance of getting a red card if you chose the VidCon cards, right? Now what I'm going to do is I'm going to put the piles together and cover them up. Which pile should you choose if you want the biggest chance of getting a red card?
It made me forget what was in there.
The VidCon one was the best both times.
It was the best both times, which makes me immediately think that it's definitely not the VidCon
That is correct.
deck.
That is correct. There are only 2 red cards out of 5 in the VidCon pile.
And there were 3.
And there were 3 red cards out of 5 in the bird pile. And so what this illustrates is something called Simpsons Paradox, which is a paradox in statistics where when you look at things in aggregate as opposed to separately, you get completely opposite results.
Or you might get completely opposite results. You might also just not get the same results every time.
Right. The point isn't that this always happens. The point is that it's possible
there are
for this to
situations
happen.
when this happens.
Often you would get the same results, right? But in this case, it has been carefully contrived so that you don't get the same results. And the reason this is relevant is because this could just be something about gambling or birds and VidCon, but it could also be that you might be set up in a situation where this first scenario was maybe you're trying to treat people for some disease, and this is like one treatment, and you say, okay, so the VidCon treatment treats more people. And in this case, you say this is a different treatment. In this case, you see, okay, so the VidCon treatment successfully treats more people, but it may be the case that these people on this side have been selected because the populations are different, right? That they have been selected for that treatment for some reason, like maybe they are getting this treatment when they already are farther progressed in the disease, so they're less likely to recover or something, and in this case, they're not as far progressed, or something like that. So this treatment on the bottom sucks because it only is 2 reds out of 5. And this treatment is better because it's 3 out of 5. But if you looked only at the treatments independently, you might say, okay, so we should do the VidCon treatment, even though maybe you should be doing the bird treatment. Or vice versa, depending on how the things are broken up. So I want to give another example using a slightly different set of cards to show how this, again, this paradox, apparent paradox kind of comes into play. So this one, we're going to have a couple groups here. Again, we're going to talk about just choosing a card at random. And so in this case, I want you to think about this one. We're going to actually put this into an imaginary scenario.
Okay.
Where this is like college admissions, okay? So, and we're talking about 2 different departments of the college, and we're talking about boys and girls. So we've got kings and queens, men and women applying to college. Do they get in or not to the department? So maybe it's the ornithology department and the film studies or whatever, right? So if you look at this one, we would say that I have it arranged such that the departments are fair on a gender basis, right? You can see that there's half of the boys that apply to ornithology and half the girls get in. And in this case,
it's like red getting in and black is not.
Yeah, red is getting in, black's not getting in. In this case, here, film studies happens to be a harder school to get into, so only 2 out of 6 boys get in, and here 1 out of 3 girls get in. So it's the same proportion. So you say, okay, this department is fair in its admissions from a gender perspective. This department is fair. But if you put them together and look at the entire university as a whole, here we're saying, okay, 3 out of 7 women who applied to the university got in, and here 3 out of 8 men. So you could say, okay, it looks like the university is discriminating against men because fewer men who apply to the university get in than women. But on the department level, each of the departments is being perfectly fair.
Right.
And this is actually, I believe, has been something that's been an issue at universities, and it depends on how you're looking at the data.
Right.
I think it was the opposite case where it looked like women were being discriminated against in one case. It's somewhat different from this, but it's a similar situation where depending on whether you look at a department level or the university level.
Right. Yeah, I mean, like this is like when we're trying to say things about the world, and this is especially feels like it's the case when you're sort of on the cusp, when it's like pretty close to being like, you might be like, well, we're getting 51% or 49%.
Right.
And you can use some tools to like say, well, what if we looked at it this way, then it's the opposite of what you might think.
Right.
But maybe it's that we shouldn't necessarily be trying to tease so much meaning out of so little data.
Potentially, although some of these things, like you can have huge amounts of data and these things still show up, these effects still show up. And one of the things that I think is interesting about this is that you can actually infer causal relationships from this kind of statistic. People often think that statistics can only tell you correlations, but there are ways of using these kinds of relationships to infer causal structure, and you basically can say, okay, so there was a cause that there was this departmental difference and more women apply, or more men, when we go back to it, more men applied to the hard to get into department than the women. That was the reason why we saw this imbalance in admissions, is because men were applying, in this case, more to department that was hard to get into, and the women applied more to the department that was easy. I think that was what was reversed in the actual case, where the women were applying to the hard departments and the men were applying to the easy ones.
Okay.
And so you can basically infer that there is a causal, common cause to these things, which is that that women and men apply to departments at different proportions. Right. And then once you understand that, all of the other patterns are explained. Even if you don't necessarily have all the details, that's something that you can get at with what's called conditional probability in Bayes' law or Bayes' rule, which is a way of looking at, well, what's the probability that somebody got in given that they were a woman, or given that they were in the ornithology department, or given that they were a woman in the ornithology department. There are different relationships between all those things. And that's what brings us to physics, because there are certain quantum mechanical phenomena that happen, like quantum teleportation or entanglement, which seem really counterintuitive. So entanglement is where you have, say something radioactively decays and you get 2 photons go out and they have correlated spins, and so this or polarizations, which is something you can measure, where no matter how far away they are, if you measure this one in a certain way, the other one is going to be opposite. The correlations are stronger than you could ever have if there were any sort of hidden underlying communication between them. It's like somehow they always know to do the right thing, even though we don't know how.
Yeah.
And the question is like, what's the causal structure of this? Like, is there a root cause when they're emitted that like propagates with them, or does somehow when you measure this one, does like that cause of then knowing what this one is propagate back in time and then forward in time on the other branch, or vice versa? Or is there some third party thing that was even farther back in time that caused them both? And the thing that I think is fascinating about this is that the folks who have studied this using this same kind of causal models that I'm talking about here, what they discovered was that none of the possible classical causal models could explain the quantum entanglement causality. So basically it was like normal probability and statistics understanding of causality did not apply. They basically had to develop new math, which was basically a quantum version of this causality, and then the quantum version of it applies to quantum entanglement.
Of this?
Of this stuff, yeah, like a quantum version of like, what's the probability that you got into ornithology given that you were a woman? There's a quantum version of that, which is a little bit more complicated.
Yeah, I might imagine.
It's already sufficiently counterintuitive, right? Which is why these are called statistical paradoxes.
Yeah.
But There's like a quantum mechanical version of that, which is a little bit more complicated. We don't know if that's true, if there's like quantum causality, but what we do know is that the causal structures that we can describe with normal statistical causality do not describe certain quantum systems.
Statistics. I think that we all need to know more of them. I mean, I'm a little bit, I'm like stuck back here where I'm like, when they're so often that you hear a statistic that gets thrown out and it's defending some kind of perspective,
Right.
and knowing that some thing that no one knows, like that these like kind of paradoxes that people just aren't aware of,
Right.
might be responsible for it. That's like, we can make like big decisions of like about policy,
huge policy decisions based on
that
statistics
stuff.
and based on
Yeah.
you know, there are so many other ones as well. There's various fallacies and where you invert things, where you think, oh, the probability of getting into the anthropology department, given that you're a woman, is the same as the probability that you're a woman, given that you got into the department, right? And those things sound the same, but they're not always the same.
Yeah.
I mean, we can do an example right here with these cards in front of us, and it probably would pan out that way.
Yeah. But you're also telling me that quantum entanglement is a statistical confusion. Maybe we thought that this thing was happening, but there was a statistical explanation for it all along. It's just weird. Does the statistical explanation, or explanation might not be the right word, but the statistical understanding of quantum entanglement, does it kind of explain what's going on? Because it's always seemed to me like this ridiculous,
The thing is that I found,
thing.
it doesn't feel particularly satisfying.
Okay.
It models it very well. It models it, the causality of it very well, in a way that doesn't feel satisfying, because it basically says something that feels like, well, both things work because it's quantum mechanics. That's kind of how it feels. In the same way that
I kind of feel that way about quantum mechanics all the time.
Right.
It works because it's quantum mechanics.
Right. But in the same, so there's this thing called the many worlds interpretation of quantum mechanics, which says like that when you have these paradoxes about like which event happens, like in Schrodinger's cat, does the cat die or does it survive when the radioactive decay happens? And it,
is there a live cat or a dead cat?
And there's because we currently don't have a mathematical description of what actually happens, why we see only one thing happen in quantum. And this is not just like crazy cat experience. It's like anytime you look at a radioactive decay and you see a decay or you don't, the question is, why did we happen to see a decay then when we could have not seen it, or vice versa?
When basically,
and so the many worlds interpretation is that there actually are all possible histories that could happen, do happen, and we just happen to follow one of those histories. Kind of like a choose your own adventure book where you read one story and then you're done, even though there are all the other ones that could happen.
So it's sort of in the same way you're looking at this photon that has been affected by or is connected to this disparate photon that could not possibly be communicating with it, and you're saying, oh, well, we just happened. It's just another one of those moments where, like, when we look, we are defining it. We're creating the state of that photon by looking at it.
I'm not sure it's exactly that.
Okay.
But it's another one of those moments where it feels like this explanation isn't as much an explanation as like you're just saying that this is the way the world is.
Right.
And
we're not explaining it. We're just saying like,
here's a way it could happen that we could never test otherwise.
oh my God.
But yeah, the statistical stuff I think is super. I think more people need to know more about statistical fallacies.
Yeah, more about statistics in general.
More about statistics.
It's just so like just Bayesian statistics, I feel like, is such a useful tool in understanding everything that goes on, and also just things like that, the probability of like how probable improbable things are.
Right.
My favorite example being like, how weird is it that I'm parked behind a car right now and the numbers on the license plate on that car are that exact set of numbers in that exact order? Like, that's so unlikely that could have happened, but it happened, and yet it has to have happened
because there are numbers on the car.
some weird order of numbers on the license plate must have happened, but that it was that particular combination is extremely improbable. But that there was some number is the definite, like, must be an outcome. improbable things happen constantly.
Yeah, it's very easy to go back and look at all the things that happen in your life, all these random chances and random events that if they had gone slightly differently, something very different would have happened.
Yeah.
But the entire universe is made up of things like this.
But something things had to happen to you. Yeah. Well, I would love for you to teach me all of statistics.
Well, I don't know it, so that's not going to happen.
Well, read up.
All right, I'll get to work. Coming to you in 10 years, 100-hour physics on statistics for Hank.
Hey, I'll pay you $10 an hour. No, I can't afford that.
That doesn't sound.
I can't afford it, and neither can you. Do you want to meet an animal?
Let's meet an animal. Okay. Yeah. Is it a statistically significant animal?
All animals are statistically significant.
All right.
These are
Get it.
big.
Get it.
I feel like these are real big.
It's like a versus right now.
Are they racing?
Gonna get it.
Wow.
Yeah, good job,
winner.
Yuka.
Nope.
I lost it.
It's going to go off the table.
Oh, good big long neck.
Oh yeah, tortoises are so inefficient at eating, I think.
Yeah, you guys are bad at this.
Get it
What kind of
done.
tortoises are these?
These are red-footed tortoises. They come from South America, and they have the red spots on them. They can be orange, and there's a subspecies of the yellow-footed tortoise as well. But they live in the rainforests and outskirts kind of the rainforest. They'll sometimes venture out to. Did she get it all the way down?
I don't think so.
Hey, here, I'll give the consolation prize. You can have a pear instead. Unless she eats it faster. She's
coming
like,
over.
hey, I got it.
You better. Oh, I love this tortoise race. It's hilarious. It's really hilarious.
This is Yuka, and this is Titus. We've had Yuka
Titus,
before.
go,
He's doing
quick!
great.
Before you
She's
lose
gonna get it. She's gonna take it. He's trying so hard.
Get away from my pear.
So they have no teeth, and they don't use their hands to eat. So it's all like beak and tongue.
I can't believe this. Titus is
guys are
embarrassing.
awesome.
This
You
is
guys
like,
are
what's
awesome.
that Hungry Hippos game?
Yeah, it's
where
like
you also
Hungry
have
Hippos.
no control over what you're doing.
Yeah, on like 240 frames per second. Hungry Hippos. It's like, whoa.
I bet you could have like some betting on this.
This is making me appreciate more.
Forks? Because that's what it's making me appreciate.
The anime,
Being able to put food into my own mouth.
Teeth,
No, the,
hands.
that movie about the animals. What was it called? With the recent one about the cop bunny.
Zootopia.
Yeah. And there's the scene with the sloth who's really slow,
Right.
and like it looks like they just did it in slow motion, but then like the tortoises are actually doing it in slow motion.
doing
Like,
it.
oh, they actually animated that.
Go, Titus, go.
I'm trying to help. We're trying to push it off the table.
Oh,
Ooh, turtle fight.
Ouch, no, I don't think he meant to do that. He was just trying to get it.
You guys.
That was a good bite.
You guys are real bad
That was
at
a
stuff.
good bite. Here.
What? So did they just find lots of pears and bananas on the forest floor?
They are primarily fruit eaters, yeah, but they'll eat. It's really interesting because
I love that.
trying so hard. Good job, Titus. Yeah, so they take these things. Look at it. She mashed it, and so they swallow these fruits whole, and then they don't digest.
My God, it's hilarious.
They don't digest very thoroughly, and so some comes out of them pretty quickly, and whole seeds. So they're seed dispersers. I like to call them gardeners of the rainforest because they'll be eating fruit over here, and they'll take a little hike, and then they'll poop over there and plant some trees, and it's all good. They don't travel really far, and each one of them has their own personality. So yeah, you ate it. You did great. So it's really interesting to study these guys because a lot of people don't recognize that reptiles have a lot of like social structure or personalities, and they totally do. So I love when new studies on tortoises come out because these guys are social, and they have communications, and they have social cues. You gonna get hurt? Yeah, there you go. You got your own this time. Oh.
Oh my God, you guys are just gonna push it right off the table.
I wasn't intending
I'm not
this
helping
to
you
be.
this time.
Oh, he had it. He had it. Oh, you
Get
see?
it?
Oh. I'll give you some. No, you can't have hers. You knocked yours off. Here.
Where are you going? Why are you so obsessed with the edge of the table? These are nice.
So why does this one have the bigger
Yeah,
bulbs?
it's interesting that you
These are
said that was
flat.
nice, Hank, because that's actually a malformation of his
That one?
his shell there. Yeah. So we've had Yuka since she was fairly young, and she had proper humidity and lighting and diet. Where we got Titus when he was 10 years old, and he did not have those things. Mostly, he was lacking a lot of humidity. And they're doing more and more studies on, is it calcium, is it lighting, is it, overall nutrition, and they've really honed it down to, I think it's the humidity during when they're just hatchlings. And if they don't have the proper care during that time in captivity, then
You get these big,
yeah,
big old
yep, huge pyramiding is what it's called. So he's a male. She's about 9, and he's about 10, 11. We've had him for a year.
So is he smaller because he's a male or because he had bad humidity when he was a
Bad
baby?
humidity. Well, the pyramiding is from the humidity, and then he is not big enough for his size. He should be larger than her. So males are larger than females, and he's older than her. So he should definitely be bigger than her.
And how do you tell
The males and females. Oh, I'm glad you asked this. This might be a little.
Should I just turn them over?
Get a little bit graphic here. So we'll look at hers first, and her plastron is going to be flatter, straight, flatter, and then if you take a look at her tail, it's tiny. It's like half a thumb, right? It's just sitting out there. Just as this little thing right here. That's her little tail. And we look at. Sorry, Titus. Interruption. Oh. Take a look at his plastron.
Oh.
See how it's indented? Very indented.
For one specific reason. Okay.
And it fits like a puzzle. And then this is his tail. From there to
It's like
there.
wrapping it around.
It is a huge tail, and it can come down about that far. Guesses on why he would need a longer tail.
So a kickstand?
It does help him maneuver a little bit. What's the most important thing in an animal's life? Like, what are they trying to do?
Sex.
Reproduce, right? Yeah. So it's a very difficult. There's some space there that needs to be achieved to make this happen. And so his
Tail,
his cloaca, where everything comes out, is at the tip of his tail. Whoa. Not at the base of his tail, where most animals. So it's like an extended cloaca.
Heard of that. That's exciting.
So he stretches it down underneath the bottom of her shell, and then the cloaca has nice and easy access.
I mean, it's like a reptile with a penis.
It is a reptile with a penis.
But it's not quite a penis because it's a tail.
But the penis comes out of the tail.
But the cloaca is not a penis, Jessi.
So the cloaca is at the end of the tail, and then this large mushroom-shaped penis
then
comes
there's a penis
out
that
of
comes
it,
out
and it's
of
like,
the tail.
So the tail comes down, goes under here, and then the penis is like,
What?
and then
That is bizarre.
Oh man, that's real weird.
It's awesome. It's really cool, and I didn't get to experience it in detail, or I knew that it happened, but I didn't get to experience it until we rescued Titus. And I'm like, what? This is really in person. This is cool.
So have they had relations?
They do. Yep.
That's the end of that story.
Yep.
Did you get turtle
what
babies or
happens.
anything? Is there?
No.
Sorry, it's tortoise.
She doesn't. Tortoise. Sorry, I missed that
Keep
too.
saying turtle.
Tortoise, and she may not produce eggs, even though they are having relations. And if she does, then she does. We're not promoting.
Right. You're not trying to
breeding
breed these
them.
guys.
And so we don't offer her a nesting site or anything like that. So the chances that she's going to actually, she's probably not going to.
So they are.
But they're social animals, and so we were happy to be able to offer Titus a home. So that, and I was worried about Yuka being lonely. So I think there's that.
They hang out in the same enclosure.
They do, and they're cool because in the wild they will follow each other. It's a common behavior, and so at Animal Wonders they make little trains, like a two tortoise train.
And these are they have plenty of habitat in their home areas?
No,
or no,
actually, these guys they're vulnerable now, so they're endangered in certain areas, but overall they're threatened, I should say. And it's due to habitat loss, but also these guys are eaten as food. Oh, she's going to the bathroom.
Oh, yay.
But see how short her little tail is? Tiny
Yeah,
little
and
tail.
just get it all up in your pee.
Well, her cloak is at the end of her tail, too.
Is
So
it?
So it's coming
She's
down.
also got like a little peer?
Yeah.
And a tail peer?
I've
Oh
got
my
some pee drippage
gosh.
there.
That's so interesting. How would that have
Blowing your
happened?
mind.
Well, I think if you think about like a snake, it's also pretty much at the end of the snake.
No, it's
But
not.
it's at the base of their
not
tail.
in the
The base
tail.
of the tail. Okay.
Yeah. Yeah. So it's cool.
I want to know, like, do you know if this is a thing with any other tortoise species?
With other tortoises, yeah, it's at the end of their tail so that
like
they can
all
reach
tortoises?
around. So they can reach around. I'm not going to say every tortoise because I don't know.
Okay, but it's a common tortoise thing.
Oh, excitement. Excitement on this end. She's trying to plant
You
a tree.
can't see what is happening right
Would you like
there.
to see?
It's not the...
Surprise!
It kind of looks like you just took what
Ooh,
they
it
just
smells
ate
great,
and put
too.
it in a blender and let it sit for a day.
So this is like banana and grape and some tortoise biscuits that we give them.
That's great.
Yeah. Now sometimes
about-
it's chunkier, like little logs, and sometimes it's not, and
Not
it's
a
just
sign
the way
of
it happens.
health.
Not a sign of health. No, it just comes out different ways. Yeah, don't knock
Don't
off
you
the table,
run
buddy.
off the
Here,
table.
have a grape. You over here.
There.
There you go, bud.
Yeah.
So these guys, they're not as long-lived as a lot of tortoises. Some of them can get to be, hundreds of years old.
And it's also pooping out of its tail. This is so interesting.
I thought this would be an interactive one.
I can't. You're telling me about their age, and I'm just like, wait,
it's
it has
pooping.
this all-purpose
It's pooping.
hole out of the end of its
It
tail?
can like whip around. My favorite is when she like totally wags her tail.
Yeah.
And it's like sometimes she'll sit there and she'll go to the bathroom and just wag it so like she makes room for more.
Yeah. Yeah, because like I don't want it to pile up all in one pile.
Yep. Yep.
Oh man.
Yep.
That,
job, you
I
got.
need to
Good
go read
job.
a Wikipedia page or two. I can't believe I
It's
didn't
cool.
know this about tortoises.
It's cool. Yes.
And anyway.
So they age.
Sorry,
so they
yes.
don't live like
Old.
to be hundreds of years old. They live like 50 to 60 years.
I mean, that's a long time.
It's still a long time. Yeah.
And these are 9 and 10, so they get much bigger, or?
Like 11 and 9.
Sorry,
Yeah. They get she's pretty much full grown. Males get a little bit bigger. They get to be about 12 inches long and 16 at the max. Like they're
Okay.
not huge tortoises.
I mean, that's pretty big. They're pretty big right now.
Yeah. I mean, I'm used to like sulcata tortoises or like Galapagos tortoises.
Yeah.
they get massive. But
And
if
these
you
are-
pick her up, like point her bum over the table and hold her, like she's heavy, right?
Yeah, that's
like she's
that's
heavier
like
than you think. What do you-
15 pounds, 20
go,
pounds.
Yeah. She is 16 pounds. Now feel him.
2 gallons of milk.
Oh, you're so little.
Yeah. Yeah. So his shell is also not as thick,
Yeah.
dense as hers. And then we're thinking malnutrition. He eats. He never stops eating. He's just so hungry all the time.
How long have you had him?
We've had him just under a year.
Okay. He eats all the time, but he's not very good at it. There you go. Get it in there, buddy.
So I was talking about what they eat. So they eat mostly fruit, and then they do this seed dispersal thing. But what's really cool about them is that they're kind of indiscriminate about what they eat. They'll eat anything, kind of anything that resembles food, and even things that don't resemble food. So they'll eat grasses and roots and bulbs and fruit. They'll eat insects. They'll sometimes eat lizards and frogs and snakes. They eat carrion.
How's a
They'll
tortoise,
find a dead
how's a
thing.
tortoise gonna catch a lizard?
It's like a dead lizard.
Yeah.
Yeah, it would eat a dead lizard, but sometimes they'll find like a dead animal and just gorge themselves on it.
Yeah.
Seems kind of gross. But they'll also eat feces. A lot of fox feces as well. We do not feed them fox feces.
But they find it.
Not at our place.
Oh.
No, but
Okay.
but in the wild they would. They would go after anything that has some sort of nutritional value.
Wow.
They're gonna gulp it down.
Gotta make it work as a tortoise.
Yeah.
It's not like food's coming to you.
Yeah. They just walk around and do their thing, eating food.
Can I ask you a question about
Yeah.
their legs,
No.
which I have noticed about tortoises before? They seem to walk with their front hands in.
Yeah.
is that typical to all tortoises? Is that
yeah, most of them. So turtles are going to be more like this, and they're going to be locomoting like this. And then tortoises, they have to lift their whole shell up, and their arms have to reach around their shells, and so like this isn't as efficient as this, being able to move that direction.
Makes a lot of sense.
So yeah, and and then they can like push this direction and move up, rough terrain, things like that. So these guys are actually interesting by the way that how they locomote. In the rainforest, it rains a lot, and so there's big mud swaths here and there, and other tortoises with heavier shell or lower legs would get stuck in it, and they'd spin out. These guys actually, they go up on stilts. They can extend their legs and go up on their tippy toes and shimmy out of the mud patches. And so right now they're all really content, and but if you lift them up, you can see that their legs extend pretty far, and she would try and hold her weight up on her tippy toes. She's not demonstrating great right now, but with a there you go.
Yeah,
there you go. See that those stilty legs? And they look really silly. Like if you see these guys walking next to a sulcata or desert tortoise, they look normal in my eyes. And then you look at these guys and you're like, why are you on stilts? So they're pretty cool.
And they're pet animals?
That's the other reason. I'm going to give them another mist down because they like to stay nice and humid in the rainforest. And you can also see their nice colors that way.
Their eyes were like,
I thank you. So habitat destruction, food source, and taking them and selling them in the pet trade. They have a ban on exporting, but they're still finding ways to export them. Tens of thousands are being exported, and
they're legal here as pets.
They're legal here as pets. In captivity, born in captivity is fine, but taken from the wild is not. So they're hunting them illegally and they're exporting them illegally. So they are threatened and close to getting that endangered listing. Yeah.
These tree rings, how old you are?
A lot of people think that. Yeah. But you learned how old she was, right?
Yeah.
So she's 9.
That's hard to get 9 out of that.
Yeah.
Yeah.
What are you guys doing? She's like,
just rubbing beats.
I want to go over there. Move. They are like little bulldozers. See, he's going to the bathroom right out of the tip of his tail.
Right out of the tip of his tail. That's not normal.
Yeah. Making little guttural Moses.
Talking about something?
She had something in her throat. Oh, rings. So it's sometimes you can tell if they've had a really good season by how big the growth ring is, kind of like trees. But it's growth patterns. So they just could have a really good season and they could have many growth rings. So you cannot. That's myth.
It's an interesting pattern, how.
Yeah, they all have 13. All turtles and tortoises have 13 of those scoots like that. They all come in different colors, little variations here and there.
That's interesting.
Yeah. And they can feel. So when you do this, they can feel through it. So Titus likes a little bit of fingernail.
Like a little butt scratch?
Yeah, so he'll get into it there. It's fun because sometimes he'll and he'll rub into it. And then Yuka likes no nails, and she likes to rub on the side here. And they don't really get into it when they're out and about because they're too distracted by so many things. But back at Animal Wonders, usually in the evening after they're nice and relaxed and full of food, scratch right there.
Are you serious? That is so
They're cool.
That's pretty cute.
Yeah. Where are you guys going?
We're going for a race.
This
We're
way.
racing.
This way. Both of them.
Yeah. Just hanging out.
Something was exciting
Well,
over there.
I didn't really know that there were reptiles that had social behaviors like that. And
absolutely.
That's really cool.
Yeah.
And I definitely didn't know that tortoises pooped out their tails.
It's cool.
I'm gonna read all about it.
I'll get a video
the rest
for
of
you
your day
too.
is filled up with.
Yeah, sorry, cancel all my appointments. I need to read about tortoise tails. Yeah. Well, thank you two for coming in and joining us. I hope and all the poop. There was a
lot of poop in this episode.
Yeah. Well, before it began, you guys had to go to the shower upstairs because there was so much poop on the tortoises. But
they pooped in their their transport crate, and then the tail was swishing, and the and it just switched everywhere, and so they took a pre-show shower.
Oh, good. Well, you are from the rainforest, so I'm sure you don't mind.
What is the substrate in their normal home?
They get dirt to walk on. We put them outside in when it's warm enough, and then we just have linoleum for most of it for easy cleanup.
Cool.
Yeah.
Cool. Thank you, Jessi. If you want to see more of what Jessi's doing, you can go to youtube.com/animalwondersmontana. If you want to see more of what Henry's doing, he's at MinutePhysics and MinuteEarth. And if you want to see more of what I'm doing, you're already here. So thanks for doing that. This has been SciShow Talk Show, and it was a pleasure having you.